Okay, today in this video, I'm going to show you how to model some fractions. So you might have the fractions that lay flat or the ones that snap like this, both work. So you have a half plus 1/4. If yours don't snap together, you just lay them next to each other, but adding is putting things together. Now on the STAR test, students cannot have ones that have labels. So you might want to find some fraction pieces that don't have labels. And then students have to be able to see that this is a half because it takes 2, this is a 1/4 because it takes 4. So ask the instructional coach on your campus where you can find some without labels for your students with special needs. Or you can print some off that don't have labels and cut them out. I'll show you the print ones in a second. So we have a half plus a 1/4. So our job is to use the other pieces to see what we can get to equal the same thing. So you just pick pieces and you try. You just let the kids explore. There's gonna be more than one right answer here. So one kid might figure out that he can take the other 4ths and it's exactly the same size. So that's 1, 2, 3/4. Another student might use the 8ths. Excuse me. And the student should be doing this, practicing, seeing how many, lining them up, and see that that's the same answer. 1, 2, 3, 4, 5, 6 8ths. And then you might have another kid who takes their 12ths and figures out how many 12ths this is. All of these are the correct answer. Gonna need some more 12ths there. The kids do the same thing I'm doing. They like really look at it and they're like, I'm not sure. Let me put some more. No, that's too big. It was right the first time. That's what we want them to do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12ths. All of those are the correct answer. And then you have a chalk about how this is the most simplified because 3 is a prime number. We got to a prime, so it's the most simplified. So fraction pieces. Let's do another one with fraction pieces. So let's say we have 3/5. And I'm just stealing these from 5.1 in the Go Math, the lesson that we're going to teach today. So we have 3/5. So let me find my fifths. Here they are. 3/5. And once again, what I was talking about earlier, you want to find blank ones. So kids have to figure out which ones are the fifths. They actually have to literally count to see which one goes in the hole. 1, 2, 3, 4, 5 times. Okay, so this is 3/5. That's why in the book you see the picture of the hole, because they're trying to get kids to remember, like, you need to figure out which one is the fifths. So there's my 3/5, and then now I got to find my half. So which one would be 2 pieces would be the same size? Okay, my pink. And now I can see that this answer is going to be larger than 1 because it's already bigger than 1. So I know it's going to be 1 and something. So I'm going to use my 1 block and I'm going to see what I can put here to make it work, Or maybe I want to use my other blocks to see what I can make it work. Sorry, I can't get them to snap. Okay, so kids will try things. They'll try all the things. Oh, that's too big. And this is what we want them to do. It might bother you because you're like, oh my God, just find the right piece. But that's okay. They're exploring. That's a little too big. If 8's a little too big, I need to find a smaller denominator. Have those discussions. Why is the smaller denominator a smaller piece? Oh, because we cut it up more times. Oh, that's perfect. So 1 and 1/10. So how many tenths is that? You might want to have a discussion. So you might want to get all your tenths. You only have so many. Let's see how many tenths are equal to a 1. If you did the previous lessons, they're already going to know 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tenths is a whole. So there's my 10 tenths plus my 1 more tenth is 11 tenths, which now we can see that's the improper and the mixed number of the same number. We just want them to keep practicing and playing with the fraction strips. Okay, now let's say that you're like, okay, I don't think I'm going to use the actual pieces. I do really encourage you to use the pieces with your students if you have them available at your school. If you don't have them available at your school, then just print out some pieces, and that's totally fine. You can have students cut them up, but in my experience, having students cut them up takes forever. So you might want to consider just leaving them like this. Now, I usually dry erase mine, put it in a dry erase pocket, so students can use the same picture over and over and over again to show their models. I don't have that at my house right now while I'm making this video for y'all. So I'm just going to show you the next problem, how I would do it with the fraction strips. So the next problem in 5.1, and I'll write this in blue, is a half, okay, good, plus 3/8. And so the first thing kids are going to need to do is they're going to need to find the half, and they're going to need to find the 3/8. So most kids instantly know this is the half, and they're going to color in the half. Let me see if I'm going to use my highlighter. So that's the piece I need, and that's why dry erase works really well for this, so they can reuse the paper over and over again. And then they got to find the 8s. 1, 2, 3, 4, 5, 6, 7, 8. Nope. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So this is 3/8. And now we're just looking for a denominator they would have in common. So literally with my dry erase marker, we just do the best we can to kind of trace the line down to see what they have in common. Oh, look, I just noticed that the half fits on the 8th line. So a half is the same thing as 1, 2, 3, 4 eighths. So now I can call this 4/8 plus 3/8, and I can use my picture and actually color that in. Here's my 4/8 from my half. This is my half. And now let's color in 3 more 8s. And now we can see that's 1, 2, 3, 4, 5, 6, 7 8s. 7 is prime, and when I skip count by 7, I don't say 8. So that is simplified as much as possible. Let me show you another one with just using the pictures. And I would strongly encourage you to make these dry erasable by just putting them in a sheet protector so you don't have to waste all this paper like I am. Okay, so now let's say that we have 3/4 plus 1/3. Well, the first thing I'm going to do is I'm going to go find my 3/4. 1, 2, 3, 4. I'm going to color it in. I don't spend too much time coloring. There's my 3/4. And now we need to find our 1/3. Here's my 1/3. And now we're going to find a common denominator by seeing where these lines will go, where they'll both hit a line. So the 4th hits this one and this one. So a 4th can be this one or this one because it lined up perfectly. I'm sorry, wrong one. Or this one, my bad. Because it lined up perfectly where their lines are. Now I'm going to do this one. Doesn't line up. Okay, it lines up with this one, lines up with that one, and lines up with this one. So the only one that they both line up with is the bottom. So I'm going to see what this would be. So 1/3 goes here. So that's 1, 2, 3, 4 out of 5, 6, 7, 8, 9, 10, 11, 12. So 1/3 can also be called 4/12. And then my 3/4 goes all the way down here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 12ths. And then we have a 4th grade problem here. We have 9 12ths plus 4 12ths is 9, 10, 11, 12, 13 12ths. And then use your fraction strips. So this is 12 out of 12. So I have one whole because I have 12 out of 12. And then I actually make my kids write the 12 out of 12 so they can remember that's the one whole. How many more to get the 13? Oh, just one. So it's 1 and 1/12. Now, if your students qualify for pieces They can get these on the STAR test as long as they have no numbers. And they can definitely have this picture as long as you just white out this up here. But not all kids get those. So some kids need to learn how to make their own fraction pieces using the graph paper. So using the graph paper. And so this is a little bit more difficult. This is for the kids that maybe are struggling using the standard algorithm and you want to show them another way. So let's say we have 3/4 plus 1/3. We got to find something they have in common before we can actually draw the model. So we can have 3/4. You can come over here and do 4 and take these 3. And then you can do 1/3 and take 1. But then the kids don't really know how to add. They don't know what you want them to do. So another way to model this is where you just draw a picture. And so you have 3 out of 4. I'm gonna make those my 4 pieces, and I'm gonna color in 3 of them. I'm gonna use the orange so I can tell where I'm coloring. 1, 2, 3. And I wanna add that. You don't actually have to use graph paper for this. I just kind of like it so I can make my rectangles the same size because we wanna show that holes are equal. And then now I'm gonna make my 1/3. They can do this on regular paper too. I just only had graph paper. So now we have the 1/3, and now we're gonna morph these pictures together to see what they can both become. So I can give this one the cross, and I can give this one the up and down. And now the pictures look exactly the same, so I can see what is their common denominator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Some kids won't believe you, it's the same. And then 1, 2, 3, 4. And then they can do the same thing. 9, 10, 11, 12, 13, 12. And then you can draw a picture to show, okay, that would be, let me get 12 pieces here. And then that would only be 12, so I would need another rectangle with another 12 pieces, because that's what my hole says, 12 pieces. And then I would color in 13 of them. 3, 6, 9, 12, 13. And then they can see that 1 and 1 12. Let me do another one of those just with white paper. So you see, you don't have to have the squares. Just the kids get the squares on the STAR test. That's why I showed it on here. Let me get a new problem from our book. Okay, let's do 2/5 plus 3/10. Okay, so you can start with your 2/5. 1, 2, 3, 4, 5, and then color in 2 of them. And now make your lines go in the opposite way. Try to make the rectangles about the same size. It's okay if you're not perfect. And now we need 10. 1, 2, 3, 4, 5, 6, 7, 8. And then you can cheat like I'm going to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I had to add 1 because I drew too big. And then I need 3. 1, 2, 3. Okay, and then now we're going to give each other the same lines that the other one has. So now I got to do 10 this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Don't worry if it's not perfect. And then, so now we have 10, 20, 30, 40, 50. 10, 20. So we have 20 out of 50. And then over here, we're going to give it the lines going this way. 1, 2, 3, 4, 5. So 10, 20, 30, 40, 50. Some kids will need to one-to-one count, and that's okay. 1, 2, 3, 4, 5, 10, 15. And then we add them up. This is just a 4th grade level problem. 20 plus 15, 35. But then the students will need to simplify because 35 over 50 is not the easiest is not the most simplified fraction. So I noticed they end in 5 and 0, and since I did my divisibility rules in prime and composite, I know 5 can go into both of these. So 35 divided by 5 is 7, and 50 divided by 5 is 10. So 7 tenths. So there's some models. Let's also talk about number lines. Can totally do number lines. I'm going to steal one of these. I like to show my kids that number lines are basically fraction strips. Try to make them the same size as best you can. So we're going to do a half plus 3 tenths. So a half, pretty easy. We got our 0. We got to put this 0 in the same place. You know what? This would probably be best to draw on graph paper so that you actually have the lines already made for you. So I would teach my kids to start with the largest denominator, which would be the 10. And then you have your 0, and hopefully I left enough to have 10. 1 tenth, 2 tenth, 3 tenth, 4 tenth, 5 tenth, 6 tenth, 7 tenth, 8 tenth, 9 tenth, and 10 tenths make a whole. And then I'm going to draw another number line the exact same size. Here's my 0. Here's my 1, and then I need to find the middle. And so some kids might automatically see the middle. Some kids might need to actually meet in the middle with their finger, and that's totally fine because a half would be right in the middle. This leads to good discussions of what does a half actually mean. And so if you have 3 tenths and you have a half, this is why it's important to think about it as fraction strips. I lined it up like fraction strips. I can now see that these line up, and I can just call this 5 tenths. So now I'm back to a 4th grade level problem. 3 tenths plus 5 tenths. And if they need to jump it on the number line, they can. Here's 3 tenths, and now I need 5. 1, 2, 3, 4, 5. And now I've landed on 8 tenths. Some kids will need to do that. Some kids won't. But once again, 8 tenths is not simplified, so you would need to show them. They can use their fraction strips. Let me show you that with fraction strips so I can show you simplification with those because I haven't shown those in this video yet. So here's our tenths. 1, 2, 3, 4, 5, 6, 7, 8. We want to find something that's the same, but with a smaller denominator. It's going to be larger pieces, smaller denominator. And the kids will just try a bunch of different things. They'll try their thirds. No, I can't do that. They'll try their sixes. They'll kind of pick all the pieces. No, I can't cut that off. And then they'll eventually find, I don't have enough of these. They'll eventually find the fifths, and they'll see, oh, that lines up. That's perfect. So it's 1, 2, 3, 4 fifths. Okay, there's some model with fractions. I just kind of stuck to basic fractions because that's what's in the first lesson where we're modeling. But if you're doing mixed numbers, you're just going to need more fraction strips and just more pieces of paper so they can draw bigger models. I would stick with the smaller fractions for models and get that conceptual understanding and then move them to the standard algorithm as your fractions are getting larger, mixed numbers, and improper. Hopefully this was helpful. We're going to be showing some more models at the training as well.